Okay, this is stats, and we're going to do the first part for section 1.3, which deals with median and mean. And it should go pretty quickly, but I didn't want to jam it into the other one, so we're just going to go 3 parts for this section. So we're on exploring data, describing numbers with quantitative data with numbers. And in the first video, we're going to do calculate the measures of centers. Sorry, I can't see very well. Again, if you can, I would print these PowerPoints out. 2 or 3 per paper would probably be better. So we're going to do this in part 1. Calculate the measures of center, the median, and mean. And we're going to do this in part 2. Well, this is going to be kind of a bigger video. And then yeah, and this is going to be about in part 3. All right, so in measuring center or the mean. So this is what most people would term as the average. Well, I should say most people. Everybody has a different way of interpreting average, obviously. But when you learned it first in school, some people actually called it the average. So the mean will forever be known as the mean in this class. I'm not going to say the average that often. The most common measure of centers ordinarily a arithmetic average or the mean, and it's just basically the sum of the observations divided by how many observations you had. So you know this one pretty well. The only difference is now you have this notation here. Okay, so this notation just means sum. Okay, the sum of all your observations, or xi, if you can't see it very well, divided by the number of total observations, right? Total observation. And now we're going to call it x, so we call it x bar. So this is the better x bar. And on the calculator, usually comes out as x bar. If I can do it really quickly, I will show you hopefully in 5 seconds. Let me see if it comes out really quickly. Does it? Yep. Okay. There you go. So on a calculator, I'll show you how to get this a little later. It's x bar and 31.25. So the mean for whatever data set that I had in my data is going to be 31.25. The other stuff, I'll explain what that other stuff is later. All right, so that's the average or the mean. All right, now the median is the one that you've known from before too. Another common measure of the center is called the median. The median is the midpoint of a distribution, the numbers such that half of the observations are smaller and the other half are larger. So it's smack dab in the middle of all of your data observations. Better known as the midpoint of a distribution, what we were calling it before. And then to find the median, you put all your observations from smallest to largest. And then if the number is odd, you can just, if you have like 15 data points, you can just, it's really easy to find that number in the middle. But if you have an even number of data points, then you find, let's say you have 3, 7, 11, I don't know, 15, right? If you have an even number, well, then you go in between. So you say, okay, well, I'm stuck between a 7 and 11. So you find the mean of those, actually. So you're actually finding the, in order to find the median, you're using a little bit of concept of the mean going on. So you would say, okay, 7 plus 11 divided by 2. 7 plus 11 would be 18. Divided by 2 would be equal to 9. So my median would be a 9, right? But if your data was odd numbered, like 3, 7, 11, 15, 21, then you would say, oh, okay, well, halfway in the middle is going to be 11. So this is going to be my median right there. Okay. All right. Now, why we want to do this. Actually, they took, this is how you do it from... use the data below to calculate the median of the commuting times. of 20 randomly selected New York workers. And I think I used this data set for, yes, I did. Okay, so we have the mean, right? This is your mean now. Is all of your data sets divided by 20 because you had 20 points of observation. So your mean is 31.25 minutes. Okay, now your median is halfway in the middle. It has to be in order first. So what they decided to do was to put it in a stem plot and find the middle. So in between, let's see, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So since you have a 20 observation points and you have an even number, you've got to go in between. So in between 20, 2 and a 0, and in between 2 and a 5. So they said, okay, 20 plus 25 divided by 2 is 22.5 minutes. Okay? So in this case, the mean is going to be bigger than the median. The median is going to be 22.5. The mean is going to be 31.25 minutes for 20 randomly selected New York workers on commuting times. All right? That's the center. That would be like the center of your distribution. So here's the problem with the mean and the median. It's really easy to calculate. The problem is in description, and more often than not, they ask you really weird questions like, what would happen, how could you describe your data if the median changes or if the mean changes? What would happen to your data? What could you say about it? So what I did was print out the same data points, 10 to 45. You do not have this on a slide, but you can watch because it's actually very informative. So I took this data up here and I made it into basically just put them in order. Now this one is the same thing. So I took all the data points up to from 5 to 85, and we calculated that the mean or X bar, I should say, is equal to 31.25 minutes. And then the median is going to be equal to 22.5 minutes. Okay, now, should not be a problem. I just put the data in order. But you will get some very tricky questions, and here's what you have to watch out for. What happens when you don't have outliers like we do in this case? What I mean by outliers in this case is pretty obvious. 85 is way out there, right? So how does an outlier change your data? If we take all this information and let's say somebody actually did a wrong data point. It wasn't supposed to be 85. It was supposed to be 67. Okay. So now the question is, should that change your median and your mean? And the question is, yes, it should. The only question is, how does it do that? How does it visually impact your data points? So we're going to calculate this. Okay. I took all the data points and I summed them up. So I have for the X bar, in this case, let me make sure you can see this very quickly. So your X bar is going to be, what did I say? 607. Okay. X bar is going to be 607 divided by 20. So I added 5 plus 10 plus 15, all this other stuff. And I got 607 over 20 because I have 20 observation points. So we have 607 divided by 20 gives me a mean of 30.35. Okay, so 30.35 minutes. And my median. Okay, so I have still 20 data points, right? I haven't changed anything. So that means I'm going to go in the middle. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 10. So I'm still between 20 and 25, right? Just like we were in the other one. Or just like we were in this one, between 20 and 25. And we say, okay, well, 20 plus 25 divided 2. What was that? 45 divided by 2. Better known as 22.5 minutes. Okay, so that should be I shouldn't say surprising, but it should hopefully strike a curiosity in your brain, because I thought both numbers would change. I don't know, maybe that was just me back in the day, but I would have sworn, I was like, oh, okay, well, I could have sworn they were both gonna change, but it only happened that the mean changed, not both the mean and the median. So here's what you need to take away from this section, from the mean and the median part. If you have the same number of data observation points, outliers will pull your mean towards your outlier, right? You will have a higher mean because your outlier is pulling your data towards a bigger number because of the outlier. But if your graph is reasonably symmetric, then your mean should be less than if you had that outlier. All right. And that's actually one of the more prominent questions, is how would this data change? How would the graph change if your mean, if you didn't have an outlier in there? So what you're supposed to typically say is that your mean tends to be less than a mean with an outlier. And it'll be easier when we get to a couple of more problems where we have to talk about the mean and the median. But that's what I wanted you to say. So it didn't matter that the median, the median stayed the same. It was more resistant than the mean when it came to outliers. All right. Now, if we had changed all of the data points, obviously that wouldn't end up being the same. But because of that outlier that we had down here, and all I had to do was change the 85 into a 67, and all of a sudden your mean dropped down. All right. But your median was the same. Okay, so that was the mean and the median, and I'll go into part 2 in the next one.